So you have this region S enclosed by y equals square root of x and x equals to 4 in the first quadrant. And let's say we want to rotate this around x equals to negative 2, which is x equals to negative 2, this line here. In order to solve this question, you really need to imagine the three-dimensional picture. Without it, you're not going to get it right. Okay, so make sure that you try to imagine what's happening. See, this one is rotated around something like this, so that if you go around, when this goes around, you're going to get something like this with, let's say this is the center, then this will also carve out another circle there, right? So that's what it's going to look like. You have like a cylinder with something inside taken out. Okay. Yeah. Try to imagine this. Okay. Make sure that you can imagine this, because without imagining this picture, you're not going to get what I'm trying to say. Okay. Are you with me? Can you imagine this? Imagine that this is going around, sweeping some volume in space. Right? What shape would it give? Okay. Use your imagination. Got it? Nod if you got it. Can you don't get it? You do get it? Okay. All right. Next, what we do is we want to get washers by dividing in some direction, right? And we see that to get washers, like two circles like that one, you have to divide that way. Okay. So that's our washer, and we need to thicken this to have some very tiny infinitesimal volume, right? So which way do we thicken it? In the y direction. Right? It has to be this way. You have to thicken it so that now this will have some volume. But this thickness is, I drew it as if it has some noticeable thickness, but it's really something we call infinitesimal, dy, infinitesimal thickness. So it's like 0. Close to 0, but not 0. Okay, so that, and I wrote dy because it's the vertical direction in the y direction. Then now we can write down the formula for calculating such a thing, which is volume is always sum of its parts. And this one we decided to be these types. This is a picture of dV that we're using, where the volume of such a thing is the area of the surface of the top, but the top is like difference between two circles, right? The area of a circle is pi r squared, and if we call the big R as the radius of the big circle and small r as the radius of the small circle, this will be the difference between the two circles, so it gives you the area of this part. And then you thicken it by dy. And that's the idea. Now, if you solve enough problems, you will realize it's always this one with either dx or dy. And you might be able to get by just by memorizing that, but I don't really recommend. It's really important for you to picture it and determine from the picture where it should be dy or dx. Okay? So we have that. Now we have several things that we need to figure out. First, we want a definite number, so it should be a definite integral. So we have to figure out what numbers to put here and there. And then because this is dy, the capital R and small r must be a function of y. Okay. So that we have to figure out. So we have to figure out capital R, small r, and also these bounds. Let's do the easier ones first. The bounds. The bounds are easy because all you have to do is go back to the picture. This is our region S. And look for the lowest y coordinate value and the largest y coordinate value, right? So lowest y coordinate means you're down here, right? So this is the lowest point. What's the y value there? What's the y coordinate value? Y will be 0 because you're right on the x-axis, right? And then if you go up, 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 what's the highest place you can go? This point, right? Okay. What is this coordinate? 2. It's 4, 2 because x is 4. Therefore, if you plug in 4 into this function, square root of 4 will be 2. So we know that the y coordinate here will be 2, and therefore this should be 0. This should be 2. Yes.
How come we wouldn't use the y for like when the function goes below 0? Because the x it goes to -2. How come we wouldn't take the y as it's going down with it?
So the question was, how come you allow x to be negative whereas y is not permitted to go down? Well, x is not allowed to be -2 at all. Here, x is at least 0. X is at most 4. So in the previous problem, when we rotate around y equals to -1, this one, we had x going from 0 to 4. It's just that, see, over here, there's nothing there.
Like if we're measuring the washer, then there's nothing that's there. We can only think it in the y. I understand why.
Okay.
Like when we're thickening the washer, we're like trying to thicken it in the y. We're not trying to like extend the diameter of the washer. You know what I mean?
No, I don't know what you mean. Okay. I don't know what to say.
No, I get it. It's okay.
You're talking about the overall diameter of the big washer or the hole in the middle?
The diameter of the
Okay. I think I see where your confusion is. So let's think about it like this. What is this symbol?
So,
What does this letter correspond to?
Sigma.
S, letter S, right? Yeah. Well, Greek letter sigma is alphabet S. Why do we use S?
It's the sun.
Because it's the sum. We're adding things, right? So we are adding all these things, but all of these small things that we're adding are parametrized by y. Do you see what I'm saying? That's the key point that I didn't explain. So that's why you're being confused here. These things are parametrized by y, so that when y is 0, it has the most material, right? So you have this, if you think about this washer, you have the biggest washer down here when y is 0. Okay? And then y becomes 0.1, 0.2, and it slowly goes up, right? Over here, you have a washer that's very thin. Right? This is like the inner radius increases so that it's very thin, right? So you should, when you see this formula, you should really think of this as like a sum of washers, but because you're adding various ones, you have to parametrize these washers somehow, okay? And that's what y is being used for. Does that make sense? Chris, I think that's where your question was really trying to get
Just
at.
have
Okay?
to stay in the range of the graph.
Yeah. So you want to stay in the range of the graph, but when you see this, you should really have this idea that when y is 0, you're down here, and you have this very thick washer, and as it goes up, it becomes thinner and thinner. Okay? Does it make sense? Right, that's why it's from 0 to 2. And it really helps. Try to use your imagination. Don't try to do this without having the picture in your mind. Okay? All right. So next topic would be to find out what r is and what small r is. They should both be function of what?
Y.
Y, because we have dy. And In this picture, at a cross section, let's say you have a cross section like that, then the big R would be from here to there. That's your big R. Do you agree? Whereas the small r would be the distance from here to there. That's your small r. So what do you, yes?
Never mind, I got it.
Okay. Are you following?
Yeah.
Okay. Yes.
So you don't, the x negative 2 is like the center of the circle?
Yeah, that's what this means, right? You're revolving around x equals to negative 2. So here is x equals to negative 2. You're rotating this around. Okay? Yeah. Yes?
Why wouldn't the big R be like lined up with 4, 2, like that point?
Oh, it's parametrized. So the question is, why shouldn't it be this one? Well, it's when I say this is a generic point in the middle, and it really starts from here and goes up, up, up until it reaches 2. So this is big R, this is big R, this is big R, and as you move up, does the big R change? It doesn't change actually. It's always from 4 minus negative 2. So this length is 6. So the big R is really the difference between 4 minus negative 2, and doesn't change it. It's a constant function. On the other hand, small r starts here as this distance will be 2, right? Negative 2 and 0, it's 2. But then it becomes larger and larger, right? And when it reaches the top, it becomes 6. So it goes from 2 to 6. Are you getting that?
The little R?
The small r, sorry.
Yeah.
Did I say big R? Okay, sorry. The small r becomes 2 here, and gradually increases until 6. Are you getting that?
I don't understand that.
You-
I mean, like, I can get it from the image,
Mhm.
but I can't get why it would be like this from the graph.
Okay, so in the image that's clear, right? This is 2, but here it's 6, right?
Yeah.
Yeah. So you have to see where these lines correspond over here. This is the radius of each cross section, right?
That means there's a bunch of little r's.
Yeah. R is a function of y. So the value of the small radius changes as you change the value of y. It becomes bigger and bigger.
Okay.
Yeah. And you have to compare this picture with that picture to convince yourself that indeed this starts from 2 and it ends up being 6, exactly like 2 becoming 6. You have to see the correspondence. All good? All right. Now we're going to say, well, this distance, horizontal distance, is how do you calculate horizontal distance?
Left hand to left.
Right minus left, right? So this will be right minus left. And I actually know what the left one is. What's the equation for the left one?
X equals y squared.
No. It's from, oh, I see. It should be this. That's why you're confused, right?
Yeah.
Yeah. It's from here to there. So that's your R. It's from here to there. And it's right minus left. Good? It's right minus left. So what is that?
Oh,
Y squared.
This was the right one.
Y squared.
Yeah, which should be written as x equals to y squared because we want a function of y.
yeah. I'm sorry, I thought
What's the left one?
it's negative 2.
X equals to negative 2, right? So if you do right minus left, the left is x equals to negative 2, and right is x equals to y squared. So that's going to be y squared minus negative 2, which is y squared plus 2. Okay, now we've figured out everything. We can now plug in and calculate. Let's factor the pi outside. 0 to 2. Capital R would be 6 squared. Small r would be y squared plus 2 squared dy.
I do have a question.
Yes.
So like, you know how the first one when it was in dx and you're trying to find little r?
Yeah.
Little r was literally just the difference between the lowest y and 0. Like that.
So in the previous question, we had the dx instead of dy.
Yeah.
For dx, we had to do top minus bottom to calculate capital R and small r,
Yeah.
because they have dx. For dy, you had to do right minus left.
The most right, like I mean, like it's like when we
No, don't think like that. You just have to see the picture where it corresponds.
No,
Where does the small r begin and end? Where does the big R begin and end? And a length is always calculated by right minus left or top minus bottom, depending on whether it's a horizontal or a vertical.
The thing is, for me, when you keep saying it revolves around x equals -2, I keep imagining like the origin point being on x minus 2.
No, it's not true. This still revolves around -2, so it gives you this circle.
Yeah. Okay.
Yeah.
No, I see now.
Yeah.
Now we need the little
Yeah.
circle at the bottom.
Yeah.
Right?
You have to picture this, or else you're not going to get it, okay? All right, so you have this, and then let's compute. This is pi 0 to 2, 36, minus y to the 4th minus 4y plus 4y squared plus 4 dy, so that it's pi integral of 0 to 2, negative y to the 4th minus 4y squared plus 32 dy, so that it's an integral of negative 1/5 y to the 5th minus 4/3 y to the 3rd plus 32y, and you're plugging in 2 and 0. And you get 32 again, 64, everything over 15, so let's see. What's that? Times 3, so it's negative 96. Times
Wait,
5.
where'd you get 32 from?
2 to the 5th power is 32. And so this part I'm just doing in my head. You should be able to calculate, right? Just evaluate 2. 32 times 5 will be 160. And then, wow, what's that? 32 times 960 over 15. So that's 800, 700 for